founder and CEO of Ecovie Water Management, and I'm going to talk today mainly about emergency water supply during a disaster. We'll touch on some other things, and to get to that, I'm going to give you a little bit of background about our company. First of all, I'm going to keep this very high level. So if you have very detailed questions, I really want to see you at our booth, which is right over there at 1221. So Ecovie, our focus is building by building, site by site, providing water solutions. So we're creating communities, resilient water communities, one building at a time. We've been around since about 2008. And what we deal with is any water that comes to a building or is generated from a building. We collect it, treat it, and use it for something beneficial. And so the sources of water could be rainwater that falls on a rooftop, very, very clean water source. We're going to talk mostly about that today. Gray water is water that comes from showers, laundry, and bathroom sinks. We treat that as well and use that for non-potable things. Black water is your kitchen and toilets. Stormwater is all precipitation, not just the water that falls on the roof, but any precipitation. And finally, there may be kind of nuisance water that we can collect and use for non-potable uses. Can you hear me? Is that better? Great. Thank you. We do have some background noise. So even though we have a small group, I need to speak up. So what we're going to mainly talk about today is using rainwater. Imagine rain that comes from, say, a big storm, a hurricane, readily available water. And what do we use the water for? What are the end uses? Could be potable sources or end uses. It can be hygienic water for showering, human contact. That's what we're going to focus on. And then all of your non-potable uses. And we're not going to focus on that for this presentation. So, speaking of an emergency water supply, why would you want to use captured rainwater or even surface water? Well, there's some things I can think about. One is it's highly available in a storm. If you're set up to collect it during the storm, after the storm comes, the power's out, maybe your other water source is contaminated, you have your water collected. And there's a lot of it. I'll give you a couple numbers in a second. We think, and we've been talking to a lot of people at our booth about different ways of getting this water and distributing it, and we're thinking about collaborating with different companies or agencies to figure out the best way to use this water. But we think there could be something in the logistics of having it locally and then distributing it out locally rather than having to fly it in and different things like that. And I'm going to go over, finally, rainwater is a very, very clean water source. So how much rainwater can you get? So you have your rooftop, water coming into a tank, many more details to it than that, but that's basically what's going on. So say you have an inch of rain, which is a little storm. An inch of rain, how much water can you get? Take your rooftop, divide by 2, and that's roughly how much water. So a gallon or square feet divided by 2, that's how many gallons or liters or however many cubic meters of water you can get. So a 2,000 square foot roof will give you about 1,100 gallons. It's a lot of water. That's a family of 4 sized home. Bigger building, say an office or an apartment building, 11,000 gallons. Big water supply, 50,000, and so on. So how much under a disaster situation do people need? I don't really know. Maybe some of you have an idea of how much water you need on an emergency basis. We usually assume in a normal situation in the US that people use about 50 gallons of water a day. which is kind of a lot. But under a disaster situation, maybe it's 10 gallons, maybe it's 5 gallons. I don't know, but assuming it's 10 gallons, this family of 4, how long would that 1,100 gallons last? 10 gallons a day, family of 4, about a month. How many? 30 days. And that's assuming it doesn't rain again in that 30 days, and it's probably going to rain. Okay, so bigger building. You can see that there's going to be an ample water supply. And imagine if it's a real hurricane, 5 inches, 10 inches, 15 inches. So is the water clean? Yes, it is. So we've done a lot of testing on captured rainwater, untreated in the cistern, and believe it or not, more often than not, it meets EPA drinking water standards. Not always, but generally. And generally isn't really good enough, we would say, maybe in an emergency situation. So we filter the water. We'll talk about the filtration. It's called Aqualoop, NSF certified, ultrafiltration, takes out all bacteria, essentially, most viruses, and the water can be collected either, we'll talk about the technology a little bit, but it's collected in a cistern and stored for use in another tank. So you have clean, potable water available through various methods of this filtration. This filtration is a form of disinfection. No chlorines needed. There's no electricity needed necessarily. So let's take a look at that. Again, if you have a lot more detailed questions on the biology or technology, come and see us. So a little bit more about this filter. It's 0.02 microns filtration, which means absolutely nothing to me. How big is that? So the green line is our filter size, and you can see some things are smaller than that, some things are bigger than that. You can see that bacteria is a lot bigger than that. The COVID virus is 6 times bigger than our pore size in our filter. So you can see that we're taking out all important pathogens. Let's look at a few alternatives of applying this technology. And here's where we've been talking to a lot of people on which applications work for different situations. And so we're getting lots of feedback on this. So I'm breaking it down into doing this filtration with no electricity, or if you have generators, or if you have an electrical source, we can do some other things in that case. And we can go from small scale to big scale. So starting with, just basic filtration, no electricity, by gravity, we can take water and filter on our smallest single filter 400 gallons per day. And you can start thinking about how many people can use that amount of water. And again, if you use that my made up number of 10 gallons of water per day, that's actually 75 half-liter bottles. Seems like a lot. We can scale up from there. Community level size, gravity, filtration with a bigger tank, bigger roof sizes, and scale it up from there. Okay? If electricity is available, it opens up the door for pumping, filling up large bottles of water for distribution, and so forth. So different scenarios we can look at, both smaller scale and larger scale, up into the 10, 20, 30, 40,000 gallons per day, if that makes sense. The other thing we're thinking about with this scenario is that we would have a possibility of mobile water treatment that could be brought into a disaster area. So there's a lot of different applications. We're looking for feedback from all of you and what makes the most sense. This is what I would consider kind of an ideal setup. Maybe you have a system that's running full time. It's your main water supply, drinking water from your rooftop. It's running with electricity, and you have a pump that's distributing it to your home. But then a disaster strikes, hurricane comes, and you can simply open a valve and have it gravity drain. So even if the power is out, you still have your water supply. I'm going to show you a couple of completed projects we've done around the world. Starting here in the US, we've done a number of potable systems on a commercial scale for large buildings. Just going to share just a couple of them. Hello. The Gulf State Park in Alabama, back in 2018, we started that system up and it's still running. There's a system at the Architectural School at Georgia Tech in Atlanta. They're using 100% rainwater, no city water whatsoever. They don't even have it hooked up. It's only water off the rooftop. So there you can see kind of the larger commercial scale. Off-grid homes, many systems up and running in the US that our company has done, and our supplier company from Germany has suppliers doing this around the world. There's an example in New Zealand. This is an example of the Aqualoop filtration, taking water out of a river in Myanmar, meeting WHO drinking water or World Health Organization drinking water standards from water that isn't particularly clear starting out, but it is after it goes through the simple filtration. Similarly, this is from Germany, taking water out of a stream in a remote area that doesn't have any water supply. So it's collecting and using the water in an off-grid manner. This is a campground in Poland where they're collecting water from a pond and providing drinking water. So just a couple examples. These aren't actually rainwater, it's surface water, but the point is that we can get to drinking water standards even starting without such a pristine water supply like rainwater from a rooftop. Okay? And that's a quick overview. I would really invite any feedback or questions or dialogue. Coming back to kind of like the different examples here, are there any ideas on where this would apply and how we might leverage the technology, especially with regard to disaster relief, or mainly hurricanes, I think?
I just don't fully understand how the filtration system works.
Okay.
How much maintenance is involved, or how often you have to change your filters.
Very good. The filter cartridges, can you hear me? I'll repeat the question. The question is, what kind of maintenance is required on the filters, on the filter cartridges? The first thing is changing them. They don't need changing. We talk about a lifespan of at least 10 years. So it's not a filter cartridge changing thing like you see in other filtering applications. If you're collecting rainwater, typically no cleaning would be required. If we're running with electricity, it does backwash on a regular basis, but actually doing maintenance should not be needed. If it is needed, it can be done mechanically or with a solution. In our gray water applications, then we do cleaning on a fairly regular basis, but it's done automatically. It's totally different application. So it's relatively maintenance free. Come by the booth, I talked about this gravity feed as it's like a huge Brita filter, but on a massive scale. Good question. Yes? Oh, as a retrofit. If you're going to use the water everywhere on a potable basis, it's much easier to do as a retrofit. If you're going to do it just for non-potable or special things, then it's difficult. You have to do it primarily when the building is being built. But if you're planning to just tap in to the main water supply with your rainwater, it's quite easy, and it's been done many times. Is that the, right? It should be possible. We would have to look at it. I'll hedge a little bit on that.
In the marketplace, there's water, salt water. A lot of people gravitate towards spring water, smart water. I've never heard anybody just offer rainwater.
Certainly. So the question is, could rainwater be sold on a commercial basis as kind of a differentiated clean water source? The answer is absolutely. It's actually done. There's a bottling company in Texas in Dripping Springs near Austin that markets their rainwater that they sell. And you can, I think it's a fantastic idea. Sorry? It is true.
Does the taste change from area to area?
Not. The question is, does the flavor of the water change from area to area? Not that I'm aware. It's condensate coming from the sky. So it's clean. It hits the roof, and like I said before, it's typically potable without any additional treatment. Not always, but typically. I do have an anecdote to build upon that, is that there's a drinking water contest, tasting contest. Are you familiar with that? In the U.S. And 1 year, the winner, and it's a lot of municipalities and different water, vendors and so forth, but the winning entry one of the years was a rainwater from a person's rainwater system. So there's that.